Okay, I'm going to show you how to do the first lesson in the labor supply online lesson. So let's go ahead and click start. You only get 2 attempts per answer box, so make sure that you are sure your answers are correct. If you end up with a low score, you can reattempt the whole thing, right? But if you're careful, you should be able to get 100% the first time through if you follow the steps. Okay, so we have this problem here in this problem here with a worker. That person derives utility, happiness, or euphoria, or satisfaction from consumer goods. So we're lumping all consumer goods and services in one thing called C, consumption. We do this in macroeconomics. We have consumption, all consumer goods added up for the entire economy. Here we're having the all goods and services consumed by this one worker, right? And their spending on consumer goods and services is the letter C, right? Now we're assuming that there's no saving, right? We're going to keep it simple. Now this person can either work so they can afford a lot of consumer goods, or they can have a lot of time off, right? Leisure is the amount of time not spent working, right? Now, this worker receives a weekly payment of $140.80. And we call this in labor and economics an allowance. So the allowance is some fixed amount of money. It could be zero. It could be $140.80, or it could be, in the millions, depending on how rich the family of the individual is, right? It could also be a lottery payment, right? The allowance could be government assistance, right? A lump sum of money given to a person, right, who's on the lower end of the income scale. It could be a food stamp benefit, right? So whatever the source of this money is, it doesn't go up or down based on how much the person works, right? The worker earns $8 an hour. So our wage rate is 8. Our allowance is $140.08 or 80 cents. Now, due to family constraints, the worker can devote up to 40 hours per week to work each week. So maybe this person's going to school, they're in high school, and they want to work, or they may want to work, but they only have 40 hours available each week because, they got to sleep and they got to go to school and they got to do homework. So this person has a maximum of 40 hours that this person can devote to either work, labor, or leisure, having fun, not working, right? Now, this model doesn't really apply to me because I love my job. I really don't like leisure. My mother-in-law keeps telling my wife and I to go on vacation. Well, if I go on vacation and leave the kids with my mother-in-law and my father-in-law, I'm going to end up working on the beach because I like my work so much. So this model doesn't apply to a lot of people, right? But I think for a lot of people, it does apply, right? I think for most people, it probably applies, right? So I think most people probably prefer not working to work, right? There's a song by the Bangles from the 1990s called Manic Monday. And if you listen to that song, the singers are like, work, it kind of sucks and school sucks because Manic Monday, wish it was, Sunday, they want leisure, right? I think so. Most people prefer leisure to work. Me, I don't. I love my work, right? I get utility out of my work. Okay, so let's move on, right? We're going to complete the following budget line for the worker. This first box is A, and A is just $140.8 per week. This right here is the value of that person's spare time spent in leisure or work. So this is just your wage rate, 8 times the 40 hours, right? Now, instead of writing as 8 times 40 in this box, I'm going to come over here to Desmos and write 8 times 40. And it ends up being 320, right? So this is the value of that person's time, and this is the allowance, right? Now, over on the right-hand side, I have three things. I have the wage rate, leisure. Excuse me. I have the wage rate and leisure plus the amount in dollars of consumer goods, right? When I multiply the wage rate by leisure, right, this is dollars per hour, and this is hours. So this right here becomes dollars. So I can add dollars to dollars, right? The price of my leisure is W. And then you can think of the price of consumer goods as one, because, you know, one times the quantities, I guess. You can think of this as the relative wage, right? Relative to the price of goods and services, right? So the price of leisure is W, and the price of consumption is one, right? So you can think of that way, right? Okay, so my wage is 8. Whoops. Somehow I got this deleted, right? All right, now I need to solve it for C. If I solve it for C, I can graph it down here in this space, because this over here is C, and this down here is leisure, right? So if I solve this for C in terms of L, then I can graph it down here. So I'm gonna do that over here. So I got 140.8 plus 320, which is 460.8, right? And so that is the sum of these two, right? And that equals my 8 times leisure plus consumption, right? So all I have to do now is, I'm going to flip these sides real quick. I'm going to move the right to the left and the left to the right. Okay, so now all I got to do is I got to subtract 8L from both sides, right? So if I subtract 8L from both sides, I end up with C on the left, and I end up with an intercept 460.8 minus 8L, right? So that is my consumption. That's my budget constraint in terms of consumer expenditures. 460.8 minus 8 times L, right? Now I can graph it down here, correct? Now the worker utility function is, we're going to keep it simple. This is utility. Again, this is the level of euphoria or satisfaction you get from consumer goods and services and leisure. And for most people, the more of both means utility increases, right? So I'm going to open up a different Desmos, right? I'm going to write U equal to the square root of C times L. Okay, now Desmos is a two-dimensional math system. I have 3 variables here. So Desmos doesn't know what to do with it, right? So what I'm going to do here is I'm going to fix one. I'm going to fix consumer goods at $100 a week. And then we're going to look at what happens to leisure, right? And what I can do is I can do one with consumer goods equal to 100, and I can do one with consumer goods equal to $120, right? So this graph here corresponds to more consumer goods. This one corresponds to fewer consumer goods, right? And you can see the one with more consumer goods generally has more, it has more utility at every level of leisure, right? Which makes sense, right? Okay, so let's look at the marginal utility of, let's look at the marginal utility of leisure. So I'm going to set X equal to 1. I'm going to change the color here to black and make it a dotted line. and make it skinnier. Okay, and then I'm going to blow it up down here. When I go from 0 hours of leisure to 1 hour of leisure, well, my utility starts at 0, right? My utility starts at, so if I make this 0, my utility is 0, right? So when my leisure is 0, my utility is 0. When my leisure is 1, what is my utility? I'm going to change this to 1. My utility is 10, right? My utility is 10. So when I go from 0 units of utility, because I have 0 leisure, and I increase my leisure by 1, I can increase my utility by 10, right? So the margin of utility of the first hour of leisure is 10, right? All right, I'm going to copy this. And I'm going to get rid of the zeros. Because now we're going to start from 1 and go to 2. We're going to go to 2 hours of leisure, right? So I'm going to go to 2 hours of leisure. When I go to 2 hours of leisure, my utility is now 14.14. I'll call it 14.1. Right? So at 1 hour of leisure, my utility is 10. At 2 hours of leisure, my utility is 14.1, right? So my marginal utility is only 4.1. So marginal utility is getting smaller. And we call that the law of diminishing marginal utility. And it makes sense if you think about it in terms of pizza. If you're really, really hungry and you go to this awesome pizza joint, you can't wait to take a bite of that first slice of pizza. And you're in such a hurry that you burn the roof of your mouth because that first bite of pizza is so good, right? But then you take the second bite of pizza and, it's still awesome, but it's not quite as awesome. And that drop off in awesomeness is your marginal utility declining. Now imagine you've had 50 bites of pizza. When you've had 50 bites of pizza, let's find out what happens. So when we're at 50 bites of pizza, right? We're asking the question, what has happened to utility when we're at 50 bites of pizza and we were at 49, right? So when we're at 49 bites of pizza and now at 50 bites of pizza, what happens to our utility? So let's change this to 49. Okay, when utility is 49, when leisure in this case is 49, utility is 70, right? It will increase this to 50. All right, so what happened to utility when we increase it from 49 to 50? Well, utility ends up being 70.7, right? So going back to our pizza example, when we take that first bite of pizza, when we go from being really, really hungry and not having any pizza to having a bite of pizza, we really feel euphoria, satisfaction, happiness, right? We have our utility increase from 0 to 10, right? That euphoria diminishes a little bit though, right? That satisfaction diminishes a little bit, that additional satisfaction, right? When we go from 1 bite of pizza to 2 bites of pizza, now we're down to a marginal utility of 4.1. Now fast forward to our 49th bite of pizza, right? When we go from 49 to 50 bites of pizza, our utility increase is only 0.7. We're getting stuffed, right? And so we're laboring to eat the pizza, right? And at some point, our utility actually might go negative. It might start dropping because the marginal utility might go negative, which means utility is actually declining because now we're about ready to puke, right? And we don't want to puke, right? So that's utility and marginal utility. And let's look at what happens when both increase from zero. So utility is zero when both are zero, right? What happens if consumption goes up by $20 and leisure goes up to 4? Our utility generally increase for both, right? So let's double our leisure, 8, and double our consumption, 40. Utility is generally increasing, right? We'll continue to double our leisure and double our consumption. So as we consume generally more of these two goods, leisure and consumer goods and services, we get increasingly happy. Okay, and that's the utility function, right? Now, if I solve this utility function, if I reset it back to L and C, if I solve this for C, the resulting equation is called what? Well, let's go ahead and solve it for C. So the first thing I have to do is I have to square both sides, right? When I square this side, I get U squared. When I square the square root of something, I get the something, right? L times C. And then all I have to do is divide both sides by L, right? I just divide both sides by L. First, what I'm going to do is I'm going to move the right side to the left and the left side to the right, right? And then I'm going to divide both sides by L. So this is going to be consumption in terms of leisure, right? Consumption in terms of leisure. If I know the utility level, right? If I know the utility level, then as I increase leisure, consumption will fall, but it doesn't fall linear, right? It falls in a way where the slope of the indifference curve gets closer and closer to zero. The slope of this indifference curve is called the marginal rate of substitution. The marginal rate of substitution is quite large here, right? What that means is if we do a small increase in L, we need a big decrease in consumption to remain indifferent. And that's why this is called an indifference curve. Why these are called indifference curves. Now, when leisure is not scarce, right? When leisure is not scarce, right? And we want one more unit of leisure, it's not scarce. We don't really value that much. So we don't really need much of a drop in consumption to remain indifferent, right? So when leisure is scarce here, right? When leisure is scarce here, we're willing to give up a lot of consumption to get a little bit of leisure, right? When leisure is not scarce, we're not willing to give up a lot of consumption to get more leisure. And that's why this curve bows, right? And that's why it's called an indifference curve. Now, there's only 4 showing in this graph, right? But in theory, there are infinite many of these indifference curves. There's infinite many here. You just can't see. I'm not drawing all of them, right? Okay, so let's fill out the table here. We're going to use the budget line first. Let's go back Desmos here. We're going to use this budget line to calculate the consumption levels, right? As our leisure increases, we're working more, right? Let's do this. I'm going to set leisure equal to, say, 16.8. And then remember, hours worked is the hours this person has available to work or leisure minus leisure. So this difference is hours worked, right? And then with hours worked equal 23.2, right? We can multiply that. I'll call that H, I guess. Yeah, there we go. I'll call that H. Okay, so I can calculate consumption 2 different ways. I can calculate consumption uses this function, or I can calculate consumption using hours worked. So I'll use a little c for that. Little c is going to be our allowance, $140.80, plus our wage, which is $8, times our hours worked. And notice these two methods give me the same amount of consumption, right? So this is my weekly allowance, and these are my wage earnings, right? This is the income, part of my income that comes from hours worked, right? From my labor. And these are non-labor earnings, right? It could be a government subsidy. It could be an allowance. It could be an inheritance. It could be lottery winnings, right? It could be food stamps. So there's a lot of examples of an allowance, and you just get it no matter how much money you make, right? Okay. All right, so let's do this. Let's fill out this table. When my leisure is 16.8 and I only have 40 hours to devote to leisure or work, I can work 23.2 hours. When I work 23.2 hours, my consumption, either I'm using the budget line or my earnings. This is the earnings equation. This is my spending equation, right? That's an expenditure equation. And this is my earnings equation. Non-labor earnings plus labor earnings, right? Both give me the same number. Okay. And then I need my utilities. So what I'm going to do here is I'm going to take the square root SQRT, parentheses. Whoop, I don't need the parentheses. SQRT, and then I'm going to type L times C, right? Because I get utility from leisure and I get utility from consumer goods. So I need to round utilities to 3 decimal places, dollar values to 2 decimal places, and everything else to 1 decimal place. So let's do that. This is 40. That's 1 decimal place, and this will be 3 decimal places, right? So 74.051. And I say 51051 because that's 7, which makes that a 1 if I round to 3 decimal places, right? All right, now let's increase leisure to 19.8. So when leisure is 19.8, I only have 40 hours to devote to leisure work. Then my hours of work has gone down, which means my earnings have gone down, which means the money I have available for consumer goods has gone down. In this case, to 302.40. Now my utility has increased. Why has my utility increased? Because at this point, leisure is very scarce. Consumption is not very scarce, but leisure is very scarce, right? So when things are scarce, you tend to value them more than things that are not scarce, right? It's like a doctor taking the afternoon off on a Friday. The doctor might make $200 an hour. The doctor takes off Friday afternoon. Why? Because the doctor was working 12-hour shifts Monday, Tuesday, Wednesday, Thursday, and decided, you know what? I've worked too much this week. I don't have very much leisure. I'm going to go play golf, right? So you tend to value things more for things that are very scarce, and you value additional levels of consumption very little when consumption is not scarce, right? So this is 77.379. We're going to keep filling in the table. So this is 22.8 now. When leisure is 22.8, my hours worked is 17.2. And my earnings, my labor earnings have gone down. Adding my lowering labor earnings to my fixed allowance means my consumption has fallen to 278.40. And my utility is still increased, right? Why? Because consumption is still relatively abundant and leisure is still relatively scarce, right? So utility is still going up, 79.671. Okay, now we're at 25.8 hours of leisure. When we're at 25.8 hours of leisure, now we're working 14.2 hours, right? And consumer goods are $254 and 40 cents. Utility still went up, but it didn't go up much, did it? It went up by a little bit, 81.016. I make that a 6 because that's a 5, which makes that a 6 when I round to 3 decimal places. Now what you're going to see is probably a decrease in utility because now, in terms of this particular consumer, leisure is not really scarce anymore and consumption is not really abundant anymore. They're kind of like at a point where they're on the margin. They're a little indifferent with small changes in either, right? So this is 28.8. Hours worked is 11.2. Consumption is, earnings have gone down. When we add earnings, labor earnings to non-labor earnings, which is constant, we get 230.4, right? 0. And our utility has gone up just a little bit, right? Just a little bit, 81.459. I make that a 9 because that's a 7. So when I round to 3 decimal places, that becomes a 9. All right, so our utility bumped up just a little bit. Okay, now we're going to 31.8 hours. Our hours of work, 31.8. Our hours of work have dropped to 8.2. Consumption has dropped down to 206.40. And our utility has gone down a little bit, right? Why? Because we're at a turning point. Now leisure is becoming abundant and consumer goods are starting to become scarce, right? So we're at a turning point. 81.016. And that's a 6 because that's a 5 right there. The fourth one's a 5. Now notice these two values are the same, right? So it looks like our utility is maximized when leisure is 28.8 and consumption is 230.40. Now your row where this occurs might be different than mine, right? Just depends on the algorithm. All right, now we're going to make leisure 34.8. Now leisure is not scarce, right? You kind of got a superabundance in leisure, right? Your earnings have dropped off because you're only working 5.2 hours a week now, right? So now consumer goods are becoming very scarce. Maybe now you're switching from hamburgers at McDonald's to top ramen, right? So consumption you have to tighten your belt. You don't get to buy your wants anymore. Now you're barely able to afford your needs, right? So our consumption is all the way down to $182.40. And our utility has dropped to 79.671. Okay. Now, like I said, the worker's utility is maximized at exactly 1 point under budget line, right? And the reason why that is because if you put a line in here, if you draw a downward sloping line, a downward sloping line is either going to intersect the curve twice, or it's going to just kiss the curve, and it'll just kiss the curve at a tangency point, right? Or the downward sloping line won't even intersect the curve, right? So the worker utility is maximized at exactly 1 point. It looks like in the table, the utility reaches a max when leisure is 28.8, right? So utility reaches a max when leisure is 28.8. Now notice when I enter 28.8 here, right? This value right here is 28.8. And when I go up, I get to my budget line, this blue downward sloping line. And notice it intersects the blue curve, the indifference curve, once. And it's just tangent to that curve at this point. And this height is my consumption level, right? So this is my optimal amounts of leisure. And this is my optimal amounts of consumption, right? And I'm optimally choosing to work 11.2 hours a week, right? Maybe I had this job at McDonald's and, you know, they were working me 23.2 hours a week, but, you know, my allowance covered a lot and, you know, I was working too much. I didn't have enough leisure. So I asked my boss to scale me back, and that boss keeps scaling my hours back until I get to the point where, you know, I can work 2 shifts a week, 2 5-hour shifts a week in the afternoon. And that makes me the happiest, right? Now, if I go any less, right? If I go any less, now it's like, you know, I'm having a hard time affording my needs. And I want to afford some wants. So if the boss takes me to 8.2, I'm not going to be very happy. So I'm going to ask the boss to set me back at 11.2 hours a week, right? The consumer goods, again, were 230.4 here. And the worker is supplying 11.2 hours a week, right? Now, remember what I said about the marginal rate of substitution here. I'm going to go back to my other Desmos. My utility level at my optimal solution is 81.459. I'm going to replace U with 81.459, and I'll be able to graph. I'll be able to graph my indifference curve. I'll change the indifference curve to blue in Desmos, and I do that by clicking on the gear, right? My y-axis goes to 500, so I'm going to change this, rotate this until I get to 500 here. So my y-axis goes, my c-axis or my y-axis goes from 500 to 0. This down here, the maximum amount of hours available for work or leisure is 80. So I got to change, I got to change the x-axis scale, right? So I'm going to click on the gear or the tool. I'm going to set the maximum of x to like, I don't know, 50. And I'll change the minimum of x to like -5. Okay. So this blue curve here is that blue curve there, right? Now, remember what I said, the slope, the curve is really steep here, right? You wouldn't want to walk up the curve from here to there. That's a lot of effort, right? But down here, the effort is quite small, right? It's a lot smaller to walk from here up to there, right? So that steepness of the curve is the slope, right? So the margin rate of substitution is very low here. The margin rate of substitution is very high here. And why is that? Because remember, if I want a little increase in leisure is scarce, right? I'm willing to give up a lot of consumption. I'm willing to give up a lot of consumption to get that little bit of increase in leisure, right? Now leisure is not scarce, right? When I go from here to there, I'm getting a little bit more of leisure, but because leisure is not scarce, I'm not willing to give up very much consumption, right? I'm not willing to give a lot of dollars in consumer goods and services, right? Because leisure is no longer scarce. And the slope of that curve is the marginal rate of substitution, right? Now let me graph the budget line in here. The budget line is C equal to 460.8 minus 8 times L, right? And again, I'll change that to blue to match the graph over here, right? And I'm going to add a point. My optimal point was what? The first point is leisure. The first number in the point is leisure, 28.8. The second number in the point is consumption, which is 230.40. And notice I have this big black dot here, right? Now, the slope of the budget line is constant, right? And we call the slope of the budget line the economic rate of substitution. And the economic rate of substitution, the slope of the budget line, is constant because it equals 8, right? So this is the economic rate of substitution. It's the slope of the budget line. It's constant, which is why we call it a line. The indifference curve does not have constant slope. Why? Because here, right, here, leisure is scarce. Consumer goods are not. So we're willing to give up a lot of consumer goods to get an additional scarce unit of leisure. Down here, consumer goods are scarce, and so we're willing to give up a very little consumer goods to get a little bit more of a very superabundant good called leisure, right? So that's why the marginal rate of substitution varies along the indifference curve, right? Now, at this optimal solution, right, if I zoom in on the point, you're going to see that when I zoom in a lot, the slope of the indifference curve, the curve itself looks like a line if I zoom in enough, right? If I zoom in enough, the curve and the budget line have become 1, right? So what that means is that at the tangency point, at this optimal consumption bundle, the slope of the indifference curve is equal to the slope of the budget line. So at this point, and only at this point, the marginal rate of substitution equals the economic rate of substitution, which is the wage rate, right? That is only true at the OS, optimal solution, right? That's only true at the optimal solution. Because if I zoom back, if I zoom out, we're going to see that the indifference curve is indeed a curve, right? See that? Okay. Okay, so down here, the marginal rate of substitution is equal to negative 8 right there, the slope of the budget line. All right. Okay, now we got to calculate our utility. If she chooses 15.4 hours of leisure and that many dollars of consumer goods and services. So what I'm going to do is I'm going to type the square root of 15.4 hours of leisure. I'm going to multiply that by the dollar value of consumer goods, 337.6. And our utility is 72.104. Now it is less than this optimal. This is the maximum our utility can be given this budget constraint, right? You can't get a higher level of utility because any other level of utility, say 82, whoops, squared. Let me go back. Okay, so this is the maximum amount of utility right here, right? Because a higher level of utility, like say 82, means the indifference curve no point on the indifference curve is affordable. We can't afford any of these consumption bundles, right? We can't afford these consumption bundles, right? So the highest level of utility with this budget constraint, the highest amount of utility she can get is 81.459, right? Now, her utility, when leisure is 15.4 and consumption is $337.60, her utility is 72.104, right? Why? Let's see what happens. I'm going to replace the maximum amount of utility she can have with this lower level of utility. Oh, 72.104. Now her utility function, her indifference curve, touches the budget line twice. Both these points right here, both these points give her the same amount of happiness. 15.4 hours of leisure and $337.60 of consumer goods gives her the same utility as 42.2 hours of leisure and $123.20 of consumer goods. Now, this point is not possible here because she can't work 42.2 hours, right? Because this person can devote up to at most 40 hours to work or leisure. So this point is actually not possible, right? Because it's beyond her 40-hour limit. Maybe her parents say you can only be out of the house outside of school, and you can only be outside of school 40 hours a week, right? Maybe they're really strict, right? Maybe they're really strict Amish or Mormons where, the parents are really strict and she's given 40 hours a week away from the house outside of school, right? So she can only work 40 hours a week, right? So this point would not be possible, right? So when I type this in and I hit enter, you'll see what happens to our graph. It ends up being on this. It ends up being on our budget line. So that point is affordable, right? We're spending exactly this amount of money, right? So this point, this bundle of leisure and consumer goods and services is on our budget line, but it's on a indifference curve that represents less utility than the one that goes through the optimal point, right? So we have less utility. So this point doesn't maximize her utility. It does a lot. I mean, she's spending as much money as she is here, but her utility is lower, right? Now, what about this point here? 31 point hours of leisure and $326.40 of consumer goods. Well, let's first find out how much utility that is. So leisure of 31.8 and consumer goods of $326.40 gives her 102 units of utility, right? So I'm going to change this to 101.880 squared. This no point on this new indifference curve is affordable, right? Because she can spend up to this line, right? She can be on this line or inside. This is the feasible region. This line represents points where she's not saving and she's spending all of her money. In here, this represents savings, but we assume there's no savings. So she can only be on the line here, right? So none of these points, none of these consumption bundles are possible out here, right? Now let's find out why. Let's plot this point. 31.8, comma, 326.4. Out here, right? So this point here is on this indifference curve, which makes sense because this is our leisure, right? That's our leisure. And this right here is our consumption in dollars, right? And so this gives us our utility, right? And this point is beyond our budget line. So this point is not affordable, right? So this point is beyond her budget constraint. And you'll see what happens in my open math. So this point gives the highest of the 3 points, 1, 2, 3. The green point has the highest level of utility, but we can't afford it, right? The person can't afford it. This point has the lowest level of utility of the 3 points, and the person can't afford it. So they're not going to choose this point. They're not going to choose this point because they can't afford that. They're going to choose this point where the budget line is just tangent to this indifference curve. Okay. Now let's find out what happens to the person's hours worked, right? Here, the person is working 11.2 hours a week, right? At a wage of $8. Now, if I were to tell you that this person was going to get a pay raise per hour, what is your gut instinct? Your gut instinct is going to be, well, if they get paid more per hour, then it makes sense, since we're at such a low level of income, it makes sense that this person will probably want to work more, right? Well, let's find out what happens. Okay, if the worker's employer raises the hourly wage rate to $10, what's going to happen? Now, to analyze this, I'm going to modify my first Desmos sheet here, right? I'm going to get rid of the 30.4. I'm going to undefine L, right? Undefine L here. I'm going to get rid of the utility function here. And then I'm going to add a bunch of rows. Okay, so the first row is going to be the wage rate. And the original wage rate was $8. And then the time constraint, she can only spend 40 hours a week working or playing. So I'm going to set that to equal to 80 or 40, sorry, 40 hours. And then her allowance from an inheritance in my model is 140.8. And this value here, I'm going to define that as B. I'm going to define this value as B here. So B equal to A plus W times T. 460.8. That's where we got the 460.8 right here, right? And then I'm gonna set L. I'm gonna undefine L. I'm not gonna define it yet. I'm gonna replace this with B. I'm gonna replace this with W. And then I'll go ahead and delete this one right here. Okay. And then I'll set L equal to what? Let's just make sure this works. Let's make sure it works here. 16.8. So if leisure is 16.8, consumption is 326.4, and hours worked is 23.2, right? 23.2. It matches that. Let's increase L up to the optimal amount of hours, 28.8. When we set L equal to 28.8, again, hours worked is 11.2. And consumption level is 230.4. Oh, let's do the utility too. Utility is the square root of L times C. And our utility here is 81.459, which is exactly that, right? Okay, so what's going to happen? What's going to happen here when the wage rate goes up? Okay, so I set the wage rate now equal to 10, right? And that means the intercept is now 540.8. So let's go to the other Desmos. The new intercept of the new budget line is 540.8. Okay, so that shifts, that's a parallel shift outward of the budget line, right? So if I undo that, notice it's a parallel shift out. Okay, it's parallel shift out. But then we got to change the wage rate, right? The wage rate is now 10. So this is going to make it steeper. So the budget line shifts outward and then rotates, right, when we change the wage. It shifts outward because the value of our time is much higher at the new wage rate. But then it rotates clockwise because the economic rate of substitution, the wage, the slope of this blue line has gotten steeper, right? So that's a new budget line, right? And then the problem says the worker's utility is maximized at 27 hours of leisure. So I'm just giving it to you, right? What I'm saying is the leisure, I'm giving you the optimal number of leisure hours and the optimal level of goods and consumers that this worker consumes. I'm giving those to you, right? So I'm going to change the point here from that to 27 hours of leisure. Then I'm going to change the consumption level to 270.4. Now notice this black point here ends up on the budget line, right? Now the last thing we have to do is we have to change the utility. So this right here is the new leisure hours. This right here is the new level of consumer goods. Well, I got to change it to 270.4. So this point has been plugged into this utility function, giving me a utility of 85.447. I'm going to replace this number up here with it. And then I'm going to backspace until I get to 4 decimal places. Because that's 7, I got to make that 4 or 5. And notice that my indifference curve is tangent at this point. So this point is indeed the bundle of leisure and goods and services that is affordable because it's on the budget line and maximizes the consumer's utility. Okay. So at this point, if I zoom this in, remember when I zoom this in, the curve starts looking like a line and has the same exact slope as the budget line, right? So although this indifference curve has non-constant slope, right? When I zoom in on this little area here, the curve looks like a line, and that line is parallel to the budget line. So at this point here, the slope of the indifference curve is equal to the slope of the new budget line, which is a negative $10. Now, when I hit enter here, you're going to see everything disappeared up here, right? The stuff that we did up there earlier, that stuff all disappeared, right? And now I'm going to do what? The worker chooses to work how many hours? Well, again, this worker has 40 hours that she can devote to work or leisure, right? 27 hours is going to be for leisure. So the difference in that is going to be our work hours, which would be 13. And when I hit enter there, see what happens? This is the original budget line with the original indifference curve. The red line is her new budget line with the higher wage. And this red curve is her new indifference curve. And her optimal solution is now at this red dot. Notice what happens here. Her leisure fell, right? From when the wage was 8 to when the wage is now 10, right? So leisure fell. Now that makes sense because remember, the wage is the price of leisure. And when the price of something, in this case, the wage goes up from 8 to 10, that's a $2 increase in price. If the price goes up, you consume less of it. So she's consuming less leisure. And because she's consuming less leisure because the price of her leisure went up, she's working more, right? She's working more. So her hours worked increase. Her hours worked were 11.2. Her hours worked is now 13. And the difference between those 2 hours is 1.8. So her hours worked increased, which makes sense, right? The wage is the price of her labor. That price going up reduces her leisure, right? Since she has 40 hours to devote to leisure work, she's going to leisure less so she can work more. And when she works more, she earns more. And when she earns more, she has more money available for consumption. What happened to her consumption level here? Well, her consumption level is $270.40, right? It was $230. So working more means she's earning more and able to consume more.